Hello everyone, welcome back to the online lecture series of fluid mechanics. And moving forward with the fluid properties, today we will be discussing a new property, which is the vapor pressure of fluids. Now it is quite a very common observation that when we place some liquid, say water or petrol, in a open container or a container which is open to the atmosphere, what happens? If you place some liquid, suppose this is a liquid, we find that the liquid molecules have got evaporated and had escaped into the atmosphere. Why this evaporation takes place? This evaporation mainly takes place because some molecules at the surface of the liquids have enough momentum to overcome the intermolecular cohesive forces of the liquid, and they try to escape from the relative confinement of the liquid state into the gaseous state. Now, what will happen if we close the container? If the same container is now closed, suppose we close it from above, and this is our liquid, what we will find? We will find that the evaporation will initially takes place, and after some time, when the vapors are in a state of equilibrium with the liquid state, then what will happen? The further transition from the liquid state into the gaseous state will stop, and the space which is in between our top covering and the liquid, it will be filled with the vapors. So we have vapor that is filled in the empty space. This is the vapor that is filled. Now, under the equilibrium condition, so we are talking about when the state of equilibrium is reached. What we mean by equilibrium is that under the equilibrium condition, we have the rate of evaporation equals the rate of condensation. Now, a measure of the extent of vaporization is the vapor pressure, which is actually the partial pressure that is exerted by the vapor onto the liquid surface. This is what we mean by vapor. We can now define vapor pressure. So let us define vapor pressure. So vapor pressure is also known as the equilibrium vapor pressure. So we will write the vapor pressure may be defined as is the pressure exerted. It is the pressure which is exerted by the vapor in thermodynamic equilibrium condition with its condensed states. By condensed state we mean either liquid state or solid state at a specified temperature in a closed system. So, we can define vapor pressure as the pressure which is exerted by the vapor in thermodynamic equilibrium condition with its condensed state, which is the liquid state or gaseous state. And by thermodynamic equilibrium condition, we mean that the vapor pressure is established when the rate of evaporation equals the rate of condensation, because when this happens, it leads to a stable concentration of vapor above the liquid. So this thermodynamic equilibrium condition means that the rate of evaporation equals the rate of condensation, leading to a stable concentration, leading to a stable concentration of vapor above the liquid surface. Now, the vapor pressure also reflects a liquid's tendency to evaporate, and it is influenced by many factors such as the nature of the liquid, the temperature, and even the presence of solutes. Now, to make things more clear, let us consider water, and we will see two conditions. So, let us consider water. We will say that we are considering water at temperature of 20 degrees Celsius and at atmospheric pressure conditions. So let us say that we are taking a closed container and we take water. The water is at temperature is 20 degrees Celsius and pressure is equal to the atmospheric pressure. Now when the temperature of the water is increased, if it is increased to 100 degrees Celsius, the water will start boiling and the liquid state of the water will get transitioned into its vapor state. So we will have the vapors that will be evolving from the water and it gets evaporated, and the space in between the top covering of the container and the water, it will be filled by vapor, and soon there will be a condition when the amount of vapor is at a saturation state. So this is the vapors that are accumulated in the space above the water surface, and this vapor exerts a pressure on the water surface, and it is that pressure which we refer to as the vapor pressure. Now take a second condition. If we take the water, same water at the same temperature of 20 degrees Celsius and P atmospheric pressure, and instead of increasing the temperature, if we try to reduce the pressure, then what will happen? If we reduce the pressure, then it affects the boiling point or the boiling temperature of water, and the water will start boiling at a lower temperature, even though the water starts boiling at a lower temperature. Now, why this happens? Because if this will happen when the pressure is equal to or less than the vapor pressure of water. So you can say that a liquid may boil even at ordinary temperature if the pressure above the liquid is less than or equal to the vapor pressure of the liquid. So this is the significance of vapor pressure, and we can easily find out in higher altitudes. In higher altitudes, in mountainous areas, we will find that the water starts boiling at a very lower temperature of say 20 degrees Celsius. Also, it will start boiling because there the atmospheric pressure is very low. So a reduction in pressure, and the pressure must be less than or equal to the vapor pressure of water. In that case also the water will start boiling.